Hi, welcome to Such and Study Tech. Today topic is multi-stage graph by using dynamic programming approach. So multi-stage graph G equal to V comma E. V is the vertex, E is the edges of the graph. Is a directed graph in which vertices are partitioned into k stages. Now we are going to find the shortest path from source S to vertex S to sink vertex T using multi-stage graph. Either you can solve this problem by using forward approach or backward approach. So these are the time complexity of the multi-stage graph. Either forward and backward approach same for the time complexity and space complexity for this graph. So here it is general DAG view, that is big of E. Time complexity you can use a stage based view. Here the time complexity is big of k into E. K is the number of stages into E number of edges. Space complexity is big of V plus E, both in stage based view and general DAG view also same space complexity for the multi-stage graph. So what is dynamic programming? Dynamic programming is a principle of optimality. What is meant by optimality? It is a optimization problem which is minimization or maximization. So here you can see this is the minimization. So you can reach from source to sink T to find the shortest path. So it is a minimization problem. And also in dynamic programming approach you can take the sequence of decisions. Is there sequence of decision is taken here? You can see, for example, you can start vertex S. This is the source vertex S. S2 next stage, this is stage 2. So here the vertex A. Then in A to reach to either D or vertex E. So here there are two edges is there, two connected edges, A to D and A to E. So you can take the sequence of decision here. Either you can go to D or you can go to vertex E. So based on the shortest path. So here it can take the sequence of decision. For example, you can see A to E is the shortest one. Then have to A to E and E to T. You can reach the sink T. So this is the shortest path. So here you can take this sequence of decisions. So you can see any directed graph is divided into, first step, directed graph is divided into number of stages. So here the source, here the stage 1 is a source vertex, only one vertex is there. Here sink T, only one vertex is there in stage, last stage, that is stage 4. So here the stage 1 and stage 2 and stage 3, here these stage 3 2 vertices is there, stage 2 3 vertices is there in this directed graph. Here stage 4 only one vertex, that is sink T. Here the stage 1 only one vertex, that is source vertex S. Now how to find the shortest path from source to sink? So here it is, I am using the forward approach. In forward approach you can fill the table in backward from sink to source, but still it is a forward approach because decisions are taking from source to sink, that is S to T. Now we can discuss here the T is reaches to T. So here the distance cost is 0. You can reach to vertex T. Next we have D to T, only one edge is there, D to T. So that is 8. So here in vertex D the cost is 8. You can reach to T, vertex T. Now you can see here in stage 3 E to T, only one edge is there, one outgoing edge from E to T. So here that is 2. Here E, the cost is 2, and which is reaches to T, E to T. So now I am applying the formula here. The cost Ij equal to minimum of C j comma L plus cost of I plus 1 and L. So here it is J and L belongs to vertex V. L is belongs to Vi plus 1. What is I? Here it is, you can see cost of Ij. So I indicates the stage number, J indicates the vertex. Now we can see, you can calculate it in stage 2 here. The cost I is a stage, that is 2, second stage. Here the vertex, J is a vertex, that is A, that is equal to minimum of C J comma L. J means here it is A, L means either D, A to D or A to E. L means Vi plus 1. I is the stage. So here the second stage. I is stage 2. 2 plus 1, that is stage 3. So you can see A to D or A to E. Now you can see A to D plus cost of I plus 1. That is stage 2. Here I plus 1 is 3. 2 plus 1, that is 3, plus L. L is D. And here A to E, minimum of A to L is E here, plus cost of stage 3 to E. So we can find out the minimum, which is the minimum CAD. So AD means the cost of the edge is 3. So this is 3 plus cost of 3D. So here you can see D cost is 8. So it is 8. So 3 plus 8, that is 11. So you can see A to E, the cost of the edge is 6. 6 plus cost of 3E. So E is, the cost of the E is 2. So it is 8. So that is equal to minimum of, which is the minimum? Here it is 11. Here it is 8. So 8 is the minimum. So you can note down here in vertex A, 8 is the minimum. Via which vertex? Either D or E. So you can see here it is via E. So A to E. So you can reach us to E. Next, same way here also you can find out B to D, B to E. So directly I can find out here without using formula. Here you can see B to D is 4. So that is equal to minimum of, here 4 plus what is the D? Here it is 8. That is equal to 12 here. Next B to E, that is 10 plus E, the cost is 2. It is also 12. So in B the cost is 12 via vertex D or E. So both are same, D or E. So next C. So here it is also stage 2, vertex B. Next cost of stage 2, vertex C. You can directly find out, here it is C to E, that is minimum of C to E is, the cost of the edge is 3 plus what is the E? So the cost is 2. And next C to T, that is 10. So here it is 5, here it is 10. So which is the minimum? So this is the minimum. 5 is the minimum. In C, 5 is the minimum. Okay, via which vertex? Vertex E. Vertex E. Now stage 1, here the cost of stage 1, stage number and vertex S. So that is equal to minimum of here it is S to A, that is 1, plus in A the cost is 8, 1 plus 8, that is 9. So you can see S to B the cost is 2, plus here B it is 12, so 2 plus 12, that is 14. Next S to C the cost of the edge is 7, plus C cost is 5, it is 5, that is equal to 12. Which is the minimum? 9 is the minimum. So you can write here 9 via which vertex? Via which vertex? That is S to A. So S to A. So what is the path here? You can see the path. You can take the sequence of decision. Once you can fill this table, then you can take the sequence of decision here. So I'm taking the sequence of decision from source to sink. So that's why it is a forward approach, but table you can fill in backward from sink to source, but still it is a forward approach. So S to A, you can reach S to S to A. S to A, then A, here it is E, A to E, A to E, and in E that is T, only one edge is there. The total cost is, so here it is 1 plus 6, 7 plus 2, that is 9. So that is equal to S to A and A to E and E to T. So here it is 2, the cost of this edge, and A to E is 6, here it is 1. So the total cost, shortest path from source to sink is 9. Next class we can discuss about backward approach in multi-stage graph by using dynamic programming approach. Thank you for watching this video.